You are bad.
210, 210. Hello, everybody, and welcome to our presentation. My name is Bogdan-Dumitru. I'm on Metro Systems Romania for more than 8 years. I'm experienced in middleware-based solutions, and during this time I have successfully managed multiple teams and implemented various projects. Currently, I am the product owner of the messaging team in Metro Systems. And today, together with my colleague SORIN Tudor, we are going to present you the Kafka implementation using Puppet in the context of digital transformation of our company. Basically, we are going to speak from our own experience, and we are going to show you how we manage Puppet, how we deploy it, how we monitor, how we secure it, what are the important aspects to be taken into consideration when managing big Kafka clusters, and what are our future plans in the next period. But first, a few words about ourselves, about the company. Metro Systems is located in Germany and Romania. Here, from our locations, we are managing the whole landscape of our company. From consultancy, development, and operations, we are providing a broad range of services, and we craft innovative IT solutions based on new technologies and using agile methodologies like Scrum and Kanban. I said that we build innovative solutions, and why do you want to provide them to our Metro group? And why does Metro wants to be in this modern retail world? Well, it's all about our customers. The advancements in today's technology have significantly changed the way the customers are buying. They are expecting a shopping experience across all channels, whether they are buying online or from their local cash and carry stores. In order to create a seamless experience for our customers and Metro to become a multi-channel wholesaler, it was necessary for the company to lay the technical fundamentals for the digital transformation of the wholesale business. And this was done by putting mobile first, meaning the company focused on building websites and applications specifically designed for mobile devices, smartphones, for example. Then the company tried to go away from the traditional big enterprise products and opt for microservices architecture. Then automation was very important. We are building continuous integration, continuous delivery, and deployment pipelines. And last but not least, we would like to keep the data in multiple data centers. So the projects that are built in this new digital transformation framework are following this new architecture approach, where development is happening in some business process-oriented verticals or domains. Let's call them domains. The development is organized on a technology stack, a common shared infrastructure platform built on cloud, and the services which are developed by these verticals are bundled in some user journeys, which represent the actual application any user can interface with. We, the messaging team, are located in the platform zone, and our mission is to provide highly available, scalable, and distributed messaging infrastructure to be able to transfer data and handle the business requirements between the verticals. Now comes the obvious question, why did we choose Kafka? Well, Kafka is fast. It can handle thousands of requests per second or even more, depending on the cluster size and the hardware used. It's scalable and cloud-oriented. Here, it's very easy to add a new Kafka node into the cluster. You can only specify the unique broker ID and provide the Zookeeper connection string. Kafka is also distributed, meaning data can be replicated on multiple clusters, multiple nodes. In case one of the nodes from a specific cluster fails, data is still available. And when this node will be back online into the cluster, data will be again replicated on it also. And it has parallel processing and stream-oriented architecture, meaning that Kafka offers a processing data engine that transforms data between different clusters. And it's called Kafka Streams. And it also supports the deployment of various connectors for building continuous data transfer pipelines. And now I will let my colleague Sorin to guide you through the presentation.
Yes, the first question that we need to answer regarding Kafka is how can we scale it and how can we implement it. Now, to scale, we need to take into consideration at first the size of the cluster. If we have small clusters or medium clusters, we can easily scale using the Zookeeper and the broker installed on the same host. For those of you who don't know, the Zookeeper is the process that manages the activities that take place in the cluster. And in case we have a medium or large cluster, we can scale it independently, decoupled, and this involves installing Zookeeper and Kafka on separate machines. Now, our recommendation is to install them differently because on a failover case, we will have a fast recovery and fast response. And also, they can be scaled independently. You don't need to scale both components at the same time. Now, no matter what option do we choose for the scaling, we have some things to take into consideration regarding the infrastructure part. That is the server flavor. And this needs to be selected depending on estimation and the load that we expect to have in the Kafka cluster. Also, we need to know that the memory that is allocated for the Kafka process, it's mainly used for the input-output operations. The rest of the things that are done by Kafka are done on the file system because Kafka caches the memory in the file system. So, knowing that as well, we will have to set up two extra things for this. First of all, the swap should be disabled for the performance reasons. And also, we'll need to use high-speed storage, primarily SSDs, and also it would be nice to have them configured using logical volume manager in order to increase them if the topics or the partitions, the number of partitions of that host increases. Last but not least, please keep in mind also the Kafka log rotate, because Kafka writes, I think, 4 or 5 logs, logs in which, depending on the level of logging, the content will be very large, and we risk to fill out the file system. Since we clarified these topics, we'll move now to the Kafka and Zookeeper installation part using Puppet. Now, for this task, we used some modules that are already available on the Puppet Forge. You can download them and use them without a problem. They are free. But before we start the implementation and the deployment, we need to know some extra information. And these informations are the zookeeper connect string used for the Kafka brokers, and also the broker list to know what brokers do we have in the cluster. We do that by querying the Puppet database, and we group our servers in the cluster by a specific ID and a specific role, so that we know exactly what to query from the database and to have a precise list. Now, this is enough for the configuration of the Kafka brokers, but we will have to generate a random ID that we will put also in the zookeeper configuration file. We try to use a function that randomly generates an ID, but we saw that on specific host names, that ID is not unique. It has happened that for different FQDNs, we have the same ID. So in that case, we just incremented the ID. Once we have those informations, we can proceed next to reconfigure or configure the Kafka broker. And the main parameters for these tasks are the zookeeper connect string that we aggregated earlier, the log directory in which Kafka will store the active logs, and which will use them. Also, the log retention period in hours or in bytes. Now, the retention periods in bytes represent the maximum value of a partition from a topic. And also some parameters that are strictly related to the topic creation, and that is the default replication factor and also the number of partitions for a topic. Of course, you can specify this also on topic creation, but if you choose not to do that, those are the default values. What do we need more in order to deploy Kafka safely in production? We'll need security, for sure. We'll need monitoring, and we'll need also tools to manage it locally or remotely. Now, on security part, there are two types of security. There is a security in which the transfer is encrypted using SSL or TLS security, transfer level security. And there is another type of security which is called SASL, but that kind of security is more in the direction of transferring data between the cluster or having a cluster that is shared between multiple clients. In our case, for the deployment, we just chose to implement the TLS security since the servers are delivered for only one customer. So in order to do that, we will need to generate the key store and the trust store. This will be done on the primary node, and it will be done using a bash script. Now, that bash script will be generated from a ERB template, a template that is used in Puppet to add specific values or variables. And the variables that we need to add to this script is the list of the servers that are in the cluster and need to be configured using TLS. Now, after the key store and trust store are generated, we'll have to configure also SSH access between the nodes. And we'll have to deploy one share resource in order to share the public key on the rest of the nodes to have access. And also we'll have to write a custom fact, something that is specific to the machines, to each machine, in which we will save if the broker is already configured or not using SSL. once the key store and trust store is generated and it's present on the machine, we'll have to configure as well some parameters that are needed in order to activate them. Now, from these parameters, there is a big list of parameters, but from this list, I would like to remind the key store and trust store location, the key store and trust store password, and also very important, the listeners and advertised listeners, including the SSL port and string, more exactly, because it's SSL and... Okay, once this is also configured, I think we have enough to declare that we have a secured Kafka cluster with SSL. Now that we covered security, we have also monitoring to cover. In order to cover monitoring, there are multiple solutions, including Prometheus or Datadog or Nagios, but we chose Datadog since it's quite easier to integrate it. For the installation of the agent on Datadog, we used also Puppet with the module that you see on the slide, that it's also available on Puppet Forge. But after the agent is installed, we will need to register it using an API key that it's stored in Hiera. Now, I know you saw on the previous slides Hiera. For those that of you that you don't know, Hiera is key value storage used by Puppet to store custom values for each machine. Okay, so once we have the agent installed and registered, there is no default integration for Kafka, so we will have to do this in two ways, in two steps. We'll have to integrate Kafka from the JMX point of view to collect the statistics, and we'll have to integrate Kafka from the process point of view. From the JMX point of view, this is also done using an ERB template. Template that it's very similar to the example given by Datadog for the JMX Kafka integration, with something specific like the host and the port. Now, for the host, you also can store this in Hiera or in Puppet, but you can easily say also local host and the port that it's used by Kafka to export the metrics. After we've done this, the metrics should appear in the Datadog portal. Now, you can also export metrics in a custom way, but be aware of the type of the metrics that you choose to export, because we've done that with the custom, with the consumer leg metric, and if we have multiple partitions and topics on one broker, then the amount of metrics is exceeded, and the Kafka portal does not receive any metrics anymore, so we'll have a gap of metrics in that period. So choose wisely what kind of metrics you want to deliver to Datadog. Now, going to the process integration. On the process integration, it's much easier. On the process integration, you have to add a process YAML file in which you specify the service and also the PID file for that service. Now, the Datadog agent will read that PID file and check if the process is running or not. Depending on that, you can also define a custom monitor that will send your alerts to whatever channel you choose, even if it's email or Slack or so. That's all with the monitoring. Now, we'll also have to cover the part with the tools that manage Kafka remotely. Since we have already the deployment pipeline and everything is done automatically by Puppet. From all of the list that is available regarding these tools, we chose Kafka Manager because it's easily accessible from the browser. And it's also very easy to build and deploy. You can easily build it using Scala build tools, using SBT, and you can upload it to a package repository from where you can also grab it and install it on the machines using package resource. Now, once this is delivered and installed, before you start the service, the Kafka Manager service, there are some parameters to be configured. First of all, there is the zookeeper list, and this is also returned by the code that I showed you earlier. And there are some settings regarding the basic authentication. Now, normally, we should have basic authentication enabled, and we can also store the username and password for the Kafka Manager in Hiera. Now, in order to change it dynamically, you will also have to deploy a custom fact, which also stores the information from the machine in order to compare it and to know it, to know if you require to change that file and restart the service. Because if you've done it in a different way, then Puppet will always rewrite your line from the config file with the new value, with the password, and that's not needed. Okay, since Kafka Manager is a pretty powerful tool, and you can manage multiple Kafka clusters locally and remotely, we advise to deploy it behind the HTTP proxy. Now, the HTTP proxy gives us two things. First of all, it gives us security. You can secure the access on it using HTTPS and the custom certificate that it's generated locally on the server. So, and it also gives us load balancing and high availability. Now, by default, Kafka Manager has some HTTP endpoints configured on port 9000 that need to be secured. And in order to do that, we will have to deploy some IP table rules that restrict the access on port 9000 only on the machines in the cluster, so they are not accessible from the outside. And that's all that you need regarding the deployment. And now I will give the word to my colleague Bogdan to...
Yes, thank you, Sorin. So what are our future plans? Where are we heading? First, we would like to integrate with the packages, the Kafka packages from Confluent, because we want to extend our service portfolio and because customers have already asked us for schema registry and REST proxy, which is available in the Confluent package. Second, we would like to build an ELK system where to send the important logs, especially the ones for the cluster state change, to be able to better debug and analyze in case of problems. And last but not least, we would like to deploy Kafka in Docker and put on top an orchestrator like Kubernetes or Mesos as a step forward for providing higher availability and self-services for our customers. And yes, this was our presentation. I hope you enjoyed it. If you'd like to find out more about the Kafka, you are welcome to come to our Metro Systems booth and Yeah.
And ask us personally.
Yes, and now if you have some questions for us, we would gladly answer them.
Yeah.
Mulțumim pentru... Mulțumim pentru prezentare.
Okay.
Dacă sunt... Am citit procesul acum câțiva ani, mulți, da, mi-am dat seama că trebuie să fii programator ca să-l înțelegi pe Kafka. Întrebări din sală pentru reprezentații Metro Systems?
Sigur. No questions?
I have one. In your
Yes.
în română sau în engleză?
As you wish.
Okay. So in your project, do you configure Kafka using high availability active or active passive?
It's active.
Okay.
So the data is replicated on all of the brokers from the cluster.
Okay. Okay.
Actively.
Because I saw that there is quite some configuration to be done to put Kafka up and running, and active makes sense. If you do this kind of configuration, then at least you have active.
Exactly.
That's the point.
Yeah.
Thanks.
Thank you.
Thank you.
Thank you. Also. Alte întrebări din sală? Ce echipă are Metro Systems în România?
Metro Systems România
Sunteți destul de mulți, nu?
Suntem destul de mulți, da, suntem pe piața din România de vreo 13 ani, avem în componență cam 800 de angajați.
Poziții deschise, poate cineva
Sigur.
e interesat?
Sigur, veniți la stand, veniți cu CV-urile și vă recrutăm.
Deci poziții deschise la Metro Systems, CV-urile se depun la stand. Mulțumim pentru prezentare.
Cu mare
Mulțumim
drag.
și noi.
O zi bună vă dorim în continuare.
Mulțumim frumos.